Good afternoon, everyone. I guess being the last presenter, I'm glad to see some of you here, so thanks for being here. I'm Sumithra Bhojan with AT&T. I work in the labs organization in Access Network. So I'm in the Access part of the network in AT&T labs. I kind of work on some of the wireline technologies like PON, GFast, relate to some of the slides that Jeff shared in the previous presentation. And I'm getting more involved into the wireless part of the business, which is more focused on Fronthaul. So today I'm going to talk about some of the white box initiatives we have ongoing with the RAN Fronthaul, for our 5G initiatives. And I do want to acknowledge my peer, Mike Mesh, who has contributed some of these specifications to OCP. So if you've been involved previously with OCP, we have a couple specifications contributed in the June timeframe. Those are available. So today I'm kind of going to give you all a highlight of what that is and what it means for the evolution, for the 5G evolution. Okay. So I'm kind of going to give you a very high-level overview or why this white box makes relevance in the 5G technology. So kind of going to start out with what we have today, with the LTE. Depending on the size of the operator's network, you will have a couple options, right? With LTE, we primarily have what I call a distributed BBU, where your base station is located close to the radio in the tower, right? And then we backhaul to the core. Or you could have what we call a centralized BBU that basically you're kind of having you have a hub location where you can have like multiple BBUs talking to the radio through Fronthaul. Here again, it's pretty much like a one-to-one. So there's no disaggregation or anything of that sort, but you gain some efficiency like power space by moving to this architecture. Today, for the Fronthaul, which is CPRI-based for the LTE, we do direct fiber or DWDM to achieve that, right? So that's all what we have today. And if you look at what we are moving towards with 5G and with the ORAN architecture, which is driving towards a cloud-based, you just have, I would call it like more flavors of implementation. In addition to the disaggregated versus centralized, now there's going to be another layer of disaggregation of like DU and CU, as well as cloudification, right? And those are being worked in the ORAN. And so the top two are pretty similar, right? It's centralizing, as well as it talks about disaggregation. And both of those will require Fronthaul transport, whether it's CPRI, eCPRI, or ROE. And you will, it's a common public radio interface. Okay, so that's the standard for the LTE radio. And if you look at what's happening on the core side, I think we've today I think or earlier we've talked about the COMAC projects, so where you kind of split the user and the control plane, and that's also again you're moving the user plane closer to the edge. So a lot of things are happening as we talk 5G, and I'm sure there's going to be a sweet spot of where all of these nodes are going to be located. So with that, I'm kind of going to focus more on the Fronthaul part of the network, which is between the RU and the DU. Okay? And here, a couple things to keep in mind are latency, that being the #1 requirement, since we're talking about Fronthaul traffic. And also, with addition of the LTE and 5G, you have different protocols, right? CPRI and eCPRI. So having an efficient and cost-effective way to aggregate multiple radio traffic back to your hub site. So those are kind of the key requirements here. Let me get into the use case of the centralized RAN. The first use case I'm going to talk about is the radio over Ethernet, and that's IEEE 1914.3 standards. if you look at the picture, you'll see like two boxes. Those are the two white boxes that we're introducing. The first one is called the Fronthaul Gateway, FHG. That's primarily targeted to go into a cell site. And the other one is called the CAS, Converged Access Switch, that's targeted to go at the hub location. So if you look at the Fronthaul Gateway function, that's primarily to aggregate both your CPRI and eCPRI at the tower, the radio, and transport via Ethernet to your hub location. So the CAS function would be to aggregate multiple macro or cell towers and be able to, whether it's an eCPRI traffic, you're able to go to the DU pooling, and that's another standard that's being worked in the ORAN community. And then if it's a traditional legacy BBU, you have the option to convert it back to CPRI and feed it to the BBU. So I'm kind of showing a mix of both because, depending on how you evolve, you could have both scenarios. And if you look at the latency that I just talked about, our budget for the fronthaul transport is 125 microsecond round-trip latency. And that's between the radio and the BBU or the DU. And it does not account for any processing that happens in the BBU. So it's strictly the transport latency. Fiber itself, if you're looking at a 10-kilometer range, so your fiber itself would be like close to 100 microseconds. That kind of leaves 25 for the 3 hubs or round trip, right? So these switches are we're targeting to be in the range of 3 to 4 microseconds latency. So that's going to be the requirement on the switching latency. Going into the radio over Ethernet, right? So we have like 3 modes that are specified in the standards. So the first one is the tunneling mode, which was pretty much like a CPRI agnostic. So you kind of encapsulate the CPRI streams as Ethernet packet. Here, we don't see any bandwidth savings. In fact, you will probably have a little bit of an overhead. The second option that you could do is line code aware. Here, what you can do is remove the 8B, 10B line coding, which I believe would account for like 20% overhead, and that equates to how much you can save on the fronthaul bandwidth. And the third one is the structure-aware mode. Here, you would need to go into the CPRI frame structure, and if you look at the antenna and the carrier containers that are in the CPRI, you'll have to kind of identify those and remove some unused containers. So that way you can get some efficiency in the bandwidth. CPRI in general is kind of, you allocate the bandwidth, right? Whether you use it or not, it's pretty much like a constant bit rate. So those are a few of the options that we've been looking at. These are kind of theoretical calculations that we have made. We don't see a huge reduction in bandwidth, but it should help. But again, you're kind of getting into the CPRI here. I would think a quick or a faster time to market would be the first one where you don't worry about any of the CPRI frames and just encapsulate them, and you'll have interoperability. It's probably going to be the fastest method. In this implementation, it does require, it's sort of like a bookended solution. So it does require 2 units to be placed in both ends. So a paired solution, so you need to have, so it does the mapping and then demapping at the other end before it gets to the BBU, since that needs to be converted back into the CPRI signal. Okay? So that's one use case. The second one is what I think I would call it like our end goal, right? That's the target. This talks about the lo-fi functionality. So here, traditionally, the BBU has the lo-fi processing. So the idea here is to offload that function and put that on the Fronthaul Gateway. So in a way, if you look at how the 5G radios are, I guess, being designed, so this function is part of the radio. So all of that lo-fi processing happens at the radio for 5G. So if I can replicate or kind of do the same thing on the LTE, then I'll have like a common, I guess, a transport to go back to your hub location. So that offloading of the lo-fi processing to this Fronthaul kind of gets me two things. One is it reduces the bandwidth to go back to the hub location, my Fronthaul bandwidth, and also it will enable the DU pooling at the CRAN hub. So in a way, you can kind of get to a unified architecture for both the LTE as well as the 5G. And that's, it applies with the ORAN 7.2x split. So if you look, just by looking at the picture, it is kind of simplified, right? So I don't need to put another node to convert it back to CPRI, and it looks much cleaner, and it should be cost effective too. So these are a couple of the use cases, and if you, in the OCP document, we have probably several other use cases documenting the Pico sites. So meaning I do have the links to at the end of the slide that you can take a look at all the use cases, and we have explained about the lo-fi as well as the ROE functionality in detail in those documents. Okay, so this is just to kind of give you all a picture of the scale. If you look at a hub location, and especially in a dense market like New York or San Francisco, you're going to have like tens to hundreds of macros or cell site being aggregated to the hub location. So I guess, so that's the function of the CAS, to be able to aggregate that. The top picture shows the macro site, so coming from different cell sites, via the 100 gig link, and you're able to distribute it to whether it's an eCPRI, distribute it to the DU pooling, so it kind of front ends the DU complex, and then the Fronthaul Gateway if you have some legacy BBU for LTE. You can also do the Pico sites. By the way, we have requirements for a Pico Fronthaul Gateway as well, a small hardened box that can be pole mounted. Fewer ports, right, for a Pico site, targeting like 8 ports. So that is also another option that you could do. But if you are, if for any reason we can't do the Fronthaul Gateway, you take the fiber here and then connect it to the Fronthaul Gateway at the hub location. So the lo-fi can kind of reside either at the cell site, I think more applicable for a macro, and for Pico, you can put that on the CRAN hub. Okay. It's the lo-fi, the processing of the BBU. Okay, it's the kind of, if you look at the BBU stack, you have your 5 function. So that's the split, the 7.2. So where you do some of the processing in the radio for 5G, and that would be the function. So today, it's a function of the BBU itself. Okay. Now, kind of getting into the specifications of the Fronthaul Gateway. I think I probably covered some of these in the previous slides on what it does. So the main function is to transport, the LTE CPRI as well as the eCPRI, supporting ROE, then the 1914.3 standards, as well as we talked about the lo-fi function. So that's the ORAN 7.2x split, being offloaded to the Fronthaul Gateway. This, also the support of TSN, which is the time-sensitive networking, and the Class C timing, that's the 1588 standards. So in terms of silicon, here we do have one, I guess, ASIC available from Broadcom, which is GA, that's called the Monterey. So that's one option that supports ROE. And the OCP document, we also have the option of FPGAs, because for lo-fi, today there is not a silicon, and that can be implemented via FPGAs. Okay. We're looking at a couple boxes here. I'm highlighting the 1U pizza box type with 24 ports of the radio ports, which would be at 10 and 25 gig support with 4 uplink back to the network. And we also have like I mentioned, for the Pico, a small hardened box which would support like 8 radio ports and 1 network uplink, and that's in our specification. Here it needs to support, the NEBS. It needs to be NEBS compliant, level 3, and the cell site class 2, which means the hardened, the temperature range -42 plus 65 C, as this box will go into like cell sites or into like cabinets. Okay. And again, in the cell site, we do have the requirement of the shallow depth. So that's the rack depth. And open edge, I think, we heard in the previous talk, that's also a good target, I guess, form factor for this device. Looking at the network capacity is, 800 gig. Talked about the latency requirements here. We're specifying a CPU with 4-core minimum, and with a BMC support for this, and the fans and PSU to be redundant as well. That's kind of our base spec we have for the OCP. Like I said, in terms of silicon, few options are available. So we're working to finalize that, on the design. So right now we do have kind of I would call it a base draft spec out there that we can work as a community. Okay. On the CAS, again, it's so these are going to be like 100 gig switches, as these will be located in the hub location, aggregating tens and hundreds of macro locations. Low latency and non-blocking switching, so we don't expect it to have huge buffers, so it's that's not a requirement here, and support the TSN and Class C timing. And here we're looking at 40 to 64. There are many options, right, in ASIC, whether it's from Broadcom, Mellanox, Barefoot. So there are many options here that can support the things that we're kind of concerned as the Class C timing. I think that's going to be the critical piece that we will be working on, the timing circuit in the CAS box. NEBS compliance, these will go into a central office or a CRAN hub location. Unlike the Fronthaul Gateway, that will need to be hardened even as a OSB Class 2. The desired form factor is a 2U, and the CPU Intel that we're looking at is an 8-core minimum with the trusted platform module and BMC support. Okay. I think that's my last slide. So I guess, I encourage you all to get engaged with the community. So we do have, like I said, specifications out in the OCP. Would encourage you all to collaborate, whether you're an operator or the supplier. We need feedback from both of you to get this product out. If you have new use cases, you're welcome to add to our use case as well. The draft specs is available in the opencompute.org wiki, and we do have monthly calls. So if you're not able to be in person, you can always attend the monthly calls for the telco group, provide feedback. Mailing list is another way to get involved. Okay. Thanks for your time, and take any questions if you have.
So there's a level of network topology. There's a level of network topology in here that I didn't imagine or know about before, like between the RU and the DU.
Okay.
And so how is that all going to get plumbed, or routed or switched? Is there do you have any vision or visibility into that?
Can you expand your question on
Well, when you're showing your network design, you've got multiple RUs coming into these new devices, this CAS switch, right? And that are going to then multiple DUs. So somebody's got to set up all that plumbing and decide.
Yes.
Right?
For the DU, I did not get into the specific of that, right? Because that's going to be worked in ORAN on the DU side, because in general, you're talking about resource sharing, right? Like multiple radios sharing resource in the DU.
Even it looks like resiliency and failover
Right. Meaning,
redundancy.
in terms of resiliency, of course, meaning if you look at what we have today, the fiber is not redundant. We don't run redundant fibers typically from cell site to the hub, but we are considering the kind of the resiliency. It's more or less, I would say, sharing load between the two CAS. It's not a fully redundant design per se, simply because the fiber is not redundant. It's single path.
But it
Right.
seems like you had fiber coming into the CAS, and then the
Right.
CAS had links to multiple DUs inside the hub site.
Right. Well, the DU, that's the DU pool, right, that will be worked out of the ORAN group. So that's yet to come on how meaning there are some, I guess, design options in the DU, how that gets designed and how you, I guess, load balance and resource share. So that's going to be another algorithm that would probably come out of ORAN. So we intend to work with the ORAN to see what's available. But in this case, I would just look at it as simple like L to L3 switching in our case, right?
Thank you.
Thank you. So I think your current simply is basically proprietary. So how do you connect?
I'm sorry, can you repeat your question? You said CIPRI?
So current 4G simply is proprietary. So I mean the vendor specific.
Right. So with this, definitely that's a challenge. The lo-fi is what would enable, right? When you offload that will become eCIPRI. But the simpler approach would be to use the ROE. So that's the use case number one I talked about, where you can encapsulate that, into Ethernet. So that way you don't have to get into the CIPRI structure. But here, in order to implement the lo-fi functionality, we do need some collaboration with the radio vendors, definitely, yes, for the CIPRI, especially for the legacy radios that exist, right?
So how about the management plane?
I'm sorry, the management plane.
Yeah, management plane on the CP.
I will have to defer that question, and I can get back to you on that.
Can you elaborate a bit on the advantages you see to using this type of tunneling or ROE versus just DWDM on both sides?
Well, few advantages, right? So white box, one thing, and you can use gray optics. With the DWDM, it does require colored optics, which are traditionally expensive. In our minds, it kind of simplifies the approach here. And the other advantage is being able to go to a common architecture on the DU side when that becomes available. We do, note the complexity, right, with the lo-fi functionality being in the Fronthaul Gateway. That's some work that we need to do in order to get there. I'm not saying it exists today, but that's what we are marching towards. Our end goal is.
Thank you.
I have a question. On the Fronthaul Gateway, are you seeing that as a white box platform, or are you seeing it could be a switch as well? I mean, it's an aggregation.
It is a switch. It is a switch, right?
Okay.
It is a switch. Our proposal is to have a white box, right? As I said, with the ROE, it's a simpler white box. When it comes to the idea here is, even though you have, the reason we put it as a white box is you could do an FPGA design, right? Where the IP can still be, in a way, closed or proprietary. But then the hardware can be common, whether I use a radio A or a radio B, I could still use the same underlying hardware and then have different IPs to the point of, how do I open the CIPRI, right? I think there are a few options that we can think about. Still having the IP provided by, I guess, the RAN. So you'll have to work out those logistics. But the hardware is what we're trying to keep it common. And what?
So you wouldn't be thinking about using maybe a white box server instead of a switch?
No, I don't think you can do this on a compute.
eCIPRI to ROE in some specialized hardware in a white box COTS server. Do you think that's an option, or?
Well, I'll be happy to learn more if you think that's a viable path.
You have spec there, but I'm just.
Right. So far, meaning the approach that we have considered is using a network switch, an FPGA, in order to do that. I'm kind of open to look at if you have ideas on using a compute for offloading. We can talk about it. Sure.
And on the backhaul side, where you had the DUs and you showed a bunch of DUs and CUs, right?
Mm-hmm.
Are you going to use Comac for that, or? I mean, how do you?
That's open, right? Meaning I'm talking about hardware. So the software that comes up, depending on how we, I guess, make progress in the open community and in our implementation, that could differ. But meaning it doesn't prevent you from doing that, I should say.
Yeah, the view is this is open hardware, and there'll be proprietary versions of software on it, and the hope is that there'll be open source options as well. Comac would be in that zone.
Right.
Sumithra, on the CAS, I noticed you had TSN as a requirement, as really the only requirement on that switch, right?
Right.
Is it packet preemption you're concerned about, or packet replication, or what part of TSN is?
Right. That's a good question. And TSN is pretty broad if you look at the standards, right?
Yeah.
We have looked at the preemption, and to be honest, I have to say, with the 100 gig, we're not noticing a big difference, right? I would say it's more or less, the time, meaning being able to, meaning it's kind of part of, I think every switch today will do the prioritization, right? That's available. And that is also part of the TSN standard. So we do have those requirements. So I wouldn't say preemption is the top priority. Simply because with the 100 gig, it doesn't.
Yeah, I didn't think above 10,
right.
10 gig.
Yeah, 10 to 25, maybe. I think it makes sense, right?
Okay.
Yeah. Yep. I do have a few other requirements, that we can share with you, just based on the standards. And I can't remember all of those numbers offhand, but I can share that with you.
Okay, thank you.
Other questions? Good. Well, thank you, everybody, for staying to the end.
Thank you.